Good morning and good afternoon, everyone, and welcome to our 2021 Summer and Tropical Weather Outlook. My name is Andrea Berg, and I am a product marketing manager here at DTN. And I am joined today by our team of long-range meteorologists, Jeff Johnson, Nathan Hamlin, and Stephen Strum, and also joined by Nick Wilson, our strategic product manager, focusing on our utilities products, and our Matt Gaffner, a solution and engineer, focusing on our GIS products. Now, I would like to go over a couple of housekeeping issues before we begin. We are recording the webinar, and we will send out a link to the recording with all attendees when it is available, probably in approximately 1 to 2 weeks from now. If you are having any technical difficulties, please message me through the chat feature, your host. I do come up as Benoit on the name, but you can please go ahead and just message the host through the chat feature. We have reserved some time at the end for any questions, but please feel free at any point during the presentation to enter your question via the Q&A feature on the right-hand side of your screen. So with that, I'm going to turn our presentation over to Jeff.
Well, thank you, Andrea, and welcome everybody. I will be starting out today the presentation covering a recap of last season, the 2020 tropical season highlights, and then be passing control over to Nate Hamlin. He will talk about 2021 and how we expect this season to evolve due to the various influences. And he'll look at some computer models to see what they're showing, and then try to put it all together in our tropical season outlook. And then Steve Strum will give additional summer season highlights, talking about different impacts that we expect beyond the tropics. And then we'll turn it over to our product managers for some industry specific insights. And then we should have some time at the end for questions that anybody may have during the presentation. So starting out with a recap of 2020, it was quite a madcap season, actually. 30 named storms, which was a record, and it's about twice the normal of average number of storms that we see during a season. There were 14 hurricanes and 7 major hurricanes. Those totals were also about double the averages. And we did set another record. 12 landfalls occurred across the U.S., and 6 of those were hurricanes. The previous record was 9 total storms, and that occurred way back in 1916. So really a terrific year in terms of impacts to the United States. Damage-wise, $51 billion in damage. It was the 5th costliest season on record, and it was the 6th year in a row with storms before the beginning of the season on June 1st. So continued a trend that has been going on now for a while. And also another trend in the last 5 years, we've had a Category 5 storm develop during the year. So really a gangbuster season in terms of tropical activity in the Atlantic Basin. Now, looking just at the storms that did make landfall in the United States, we have a list of all of the storms there on the left. On the right would be a map of where the landfalls occurred, and the color codings represent in blue a tropical storm. Category 1 hurricane is in the pale yellow. A little bit medium yellow shade was Category 2, and then Category 4 in red. So visually you can see that the strongest hurricane was Laura, that hit southwest Louisiana during late August. But as I mentioned, we did have another early season event, Tropical Storm Bertha, in late May. That particular system did move into South Carolina. Then another tropical storm in early June. Third system occurred in mid-July, Tropical Storm Faye. That one actually occurred up in the New Jersey area. And then several hurricanes or a streak of hurricanes occurred with Hannah in late July. That one moved into southern Texas with winds up to 90 miles per hour. Then a real problematic storm occurred shortly thereafter. A Category 1 hurricane with 85-mile-an-hour winds at landfall. It moved into northeastern South Carolina, but Hurricane Isaias then moved northward up the eastern seaboard and did produce quite a bit of damage as it did maintain its intensity with fairly strong winds all the way up the east coast. Part of the circulation did stay over the ocean, so it did maintain a lot of those tropical intensities all the way up, as well as there were a number of severe storms and tornadoes associated with the circulation. And then in late August, we had Hurricane Laura move into southwestern Tennessee, as I mentioned earlier, with winds of 150 miles per hour at landfall, so very destructive in terms of wind damage, let alone the storm surge along the coastline. And then a little bit weaker system, Hurricane Marco moved into southeast Louisiana with just 40-mile-an-hour winds at landfall. And then Sally in mid-September into southwestern Alabama, 105-mile-an-hour peak wind at landfall, and then Tropical Storm Beta, and then another set of stronger hurricanes, Category 4 Hurricane Delta in early October with 100-mile-an-hour winds at landfall, and that one also hit pretty close to where Laura came in. And then Hurricane Zeta, another strong one, 110-mile-an-hour winds at landfall, again affecting Louisiana. And then a pretty late season event, a Category 4 hurricane. But fortunately, when that did impact the United States, the two landfalls just had peak winds of 60 and 50 miles per hour in Florida. Another way to look at these storms on the left, the same list, but the amount of damage that occurred with those events. The big one was Hurricane Laura in southwest Louisiana, but Isaias also pretty costly at nearly $5 billion. And then Sally, $7.3 billion. And then Ada, even though it was a weaker storm, did produce almost $8 billion. The map on the right shows the coverage of the warnings and that were issued for hurricanes and tropical storm force winds. So the yellow shading represents winds that were in that roughly 40 to 75 mile an hour category. So much of the eastern seaboard, as well as Florida, and then well inland into the southern Appalachians region, those areas were impacted by tropical storm force winds. So it's not just the coastline that was impacted. The storms did move well inland and produce some damage. So that was a quick rundown of last year. Normally we would go into detail of individual storms, but just due to time and so many storms, I just wanted to catch the highlights in there. I have just a few slides here to look at long-term trends because people may wonder, is this something out of the ordinary? And um, what we've seen over the last 120 years or so is the number of landfalling hurricanes in the U.S. has actually been on a slight downward trend. Lots of variability from year to year, but more recently, in the last few decades, we have had lower numbers of landfalls. And that was also true with major hurricane landfalls in the United States. In fact, we had a real quiet period in there between 2006 and 2016 where no major hurricanes made a landfall in the United States. And you can see that big gap there on that graph. Usually the major hurricanes on the average come in every couple of years or so. So having a 11-year gap in there was highly unusual and kind of made up for lost time here last year with all of the landfalls, trying to even out the score a little bit. Another point I'd like to make is it's not just the wind damage and storm surge, but rainfall is a very significant part of tropical cyclones. This map shows the record rainfall with this tropical cyclone for each state. So just looking at some of the big ones here, Texas, over 60 inches of rain, and that just occurred a few years ago with Harvey. Florida, max of 45 inches, but even up through the Carolinas, we get 25, 35 inches of rainfall. So extreme flooding is certainly a possibility with even a weak tropical system. So just some important historical factors we like to keep in mind, so we have some perspective on what hurricanes have been like over the last century and a half. As I mentioned, we've had fewer landfalling hurricanes during the past 10 to 15 years, excluding 2020. That quiet period was very unusual compared to the last century and a half. We had no major hurricanes making landfall between late October of 2005 to August of 2017, and that was a record span. But since 2017, we have had four majors make a landfall. And it's important to realize that the impacts from a storm of sufficient intensity located in exactly the wrong place has shown that disruptions can be quite significant and costly. A couple examples would be Superstorm Sandy and Hurricane Harvey. And when these landfalls and intensities catch up with the historical distributions, the costs are going to be much greater due to our continued growth in our exposure, our vulnerability, and wealth of property that's put into these areas. So when we have a storm come in and intersect these growing areas of population centers, the risk of damage just is going to continue to increase with time. And landfall upon a dense population and infrastructure increases that threat for widespread property damage and loss of life. And there is also some evidence recently that storms have tended to slow down or stall near the North American coastline, and that has led to some higher rainfall rates. So flooding has become more of a concern in recent years. So lots of things to keep in mind here from a historical perspective. Lots of variability from year to year, but um, we really were kind of lucky there in that period in the last 10 to 15 years, excluding 2020, where the U.S. was missed a lot. But if we start catching up to the historical norms, um, we, we, may, we may encounter a lot more activity than what we've been used to in recent years. So to talk about 2021, I will now pass control over to Nathan.
Very much, Jeff. It's very important to keep that historical perspective in mind when you evaluate the forecast that we are about to give. But before we get into that, let's take a look at the seasonal averages. Now that we've gone through 2020, we have an opportunity to update our 30-year average. From 1981 to 2010, we had 12 named storms, 6 hurricanes, and 3 hurricanes on average each year. And now that we're using the 1991 to 2020 normals, you'll notice that it has come up a little bit. 14 named storms, 7 hurricanes, and 3 major hurricanes is the new average. Let's take a look at some important seasonal factors. Tropical development is enhanced when the following occurs. Ocean temperatures are warmer than average, so think of it as more fuel that these storms can use to grow. Vertical wind shear, or changing of winds with height, is weaker than normal. So if all the winds are blowing from the same direction at the same speed from the surface all the way up through, these storms are more likely to strengthen, they become more organized, whereas if you have different directions and different speeds, these storms tend to become more disorganized and spread apart. And it also helps if you have a large-scale rising air motion environment in place. And if you put all 3 of those together, you have the opportunity for significant development. Our favorable hurricane season conditions. So the main development region we speak about is the tropical Atlantic west of the African coastline all the way through to the Caribbean Sea. And if you have a stronger and wetter West African monsoon, it tends to spit more waves and stronger waves westward off of the African coast. And if it can interact with the favorable conditions that we just spoke about, you get the opportunity for development of organized tropical systems. Whereas if you don't have the stronger and wetter monsoon season, you get less waves, less opportunity for explosive development in this region. So as we always do, let's take a look at the main seasonal drivers. And what you see on the right is a forecast for June, July, and August, the average sea surface temperature anomalies. So where the reds and oranges are, that's above normal water temperatures. The blues are below normal water temperatures. And first place we look is the ENSO region, which is the tropical Pacific, just west of South America. And you can see some mixed colors in there, a little bit of orange on the right, a little bit of blue in the middle, and a little bit of blue off to the south. So it's pretty neutral. We don't have a La Nina or an El Nino in the forecast going forward here, so neutral ENSO conditions. Looking further north in the Pacific Ocean, you have a cold phase or the minus PDO. Well, basically what that means is that you have some cooler water right along the US coastline. You have warmer water to the west of that. So you can see it from the south of Alaska and then further west from there, a lot warmer than it is along the US coastline. So that's another thing we look for. And then on the Atlantic side, you see all the oranges pretty much everywhere. So a warmer than normal Atlantic Ocean here. So what we do is we look through the historical record and find summers that have some water temperature profiles similar to this. And that can give us some clues as to what might be coming. And let's focus on ENSO since it's one of the more important factors going into the forecast. And going through the summer and the fall, all those lines you see are different forecasts with modeling centers all across the world. And to be El Nino, you want to have the temperature anomaly in the ENSO region to be 0.5 degrees Celsius or higher. For a La Nina, you want to have it minus 0.5 degrees Celsius or cooler, and anything else in between is a neutral. And you can see all those blinds, no matter what one you look at almost, through the summer and fall, are squarely in the neutral category. There are a couple outliers that sneak up into the El Nino category, and one very aggressive outlier in the La Nina category. Those are highly unlikely. There's a high chance here we're going to end up the summer and into the fall through the hurricane season with neutral ENSO. And why does ENSO matter? Well, it has a significant statistical influence on the amount of storms that form. So focusing on named storms, hurricanes, and major hurricanes, if you look at it, if we ignore everything since 1950, and we focus on everything since 1995, all years since 1995, average of 15 named storms, 7 hurricanes, and 3 major hurricanes. However, if you look at the El Nino cases since then, that's significantly lower. 11 named storms, 5 hurricanes, and 2 major hurricanes. So a significant step down. Neutral and La Nina are associated with potentially more active seasons. So you can see 16 named storms. Then you have 8 or 9 hurricanes and 4 majors. So when you have a La Nina or neutral ENSO, chances are you'll have an enhanced Atlantic hurricane season. So with that in mind, let's take a look at some analogs, some average weather conditions, as we spoke about before, similar ocean temperature profiles that are expected this year. And our top 6 analogs are listed and all the tracks of storms that occurred that year. And there's a couple of things that stand out. If you look at the more modern ones, let's say from 2001 onward, you can see there's a fair amount of storms out there, for the most part, a bunch of hurricanes, and near above average major hurricanes. But one thing that I can see looking at the tracks is you get a lot of them that try to come westward through the tropical Atlantic and then curve to the north and then curve to the east. And there's a lot of that going on, and very few of them are able to get through and get into the Gulf. Most of the stuff that gets into the Gulf are more or less homegrown or grown in the Western Caribbean Sea. So the analog years show a more active season, but it does not show the enhanced U.S. landfall rate, threat that everything showed last year. Let's take a look at the averages here. And again, the 1991 to 2020 historical average, 14 named storms, 7 hurricanes, 3 majors. If we use 1995 plus neutral ENSO years, that's 16, 8, and 4. Our Analog show 14.7 named storms, 7.5 hurricanes, 3.2 major hurricanes. So what that means is that it's slightly above the 1991 to 2020 historical average. And so that does suggest a slightly more active year. Looking out the window right now at current sea surface temperature anomalies, you see a few things that are concerning. More or less all that orange, all those warmer than normal water temperatures from, let's say, the Bahamas, the Caribbean, and across the tropical Atlantic. So there's a lot of fuel out there to work with. And again, it's forecast that all the water closer to the U.S. coastline is a little cooler right now, but that will change as we get into hurricane season. And you see the coolness that's in the tropical Pacific and the ENSO region. We're headed into ENSO neutral conditions, and this backs that up. And forecast again from the CFS, they'll show on the left all that orange above normal water temperatures for pretty much everywhere that we care about in the Atlantic Basin. And but the concerning thing to me is looking on the right where the wind shear graphics are. So when you have the blues in those areas, you have lower than normal wind shear. That's a favorable parameter for tropical development. So if you have warm water and less than normal wind shear, that is certainly concerning as we look forward into the hurricane season. And having looked at these models over and over again, they have been showing the same thing for a while now. One thing we'll have to watch is the rainfall forecast for the European, and there's some yellows in the Caribbean into the tropical Atlantic. That's indicative of below normal rainfall. That can be thought of as a signal for reduced tropical activity. This model does happen to have a dry bias in those regions here that we have to worry about a little bit, but this is a factor that is a little bit is favoring maybe not quite as an active season. You do see some greens out into the open Atlantic and then in portions of Gulf, central and northern Gulf of Mexico. So that would suggest the possibility of storms somewhere in there. So again, it's not completely prohibitive, but it's not the most favorable signal there. So let's move forward to upper air patterns influencing the U.S. landfall frequencies. And here we're going to look at some 500 millibar anomalies, and the one on the left is that lower landfall period that Jeff spoke of earlier, 2006 to 2016, where very few storms made landfall in the U.S. And you can see a trough, low pressure, right along or just inland from the east coast, and air flows counterclockwise around that. So it actually is kind of a brick wall. So storms that want to come westward across the main development region towards that are going to be picked up, curved to the north, and eventually curved out to sea. And that tend to happen quite a bit there. Now, if you look at 2020, the one on the right, you see a few differences. First thing is that trough was pushed inland all the way to about the Mississippi Valley, low pressure across central or south central Canada. You have a ridge of high pressure that took up residence from Canadian Maritimes all the way through just about the New England coastline and then edging down the eastern seaboard. So storms that were able to come westward were not picked up. They were steered. They were blocked from turning north, and they were steered westward through the Atlantic and then in towards the U.S. and the Gulf of Mexico. And that was a very favorable pattern for an active season, and sure enough, many storms ended up doing just that. So let's compare that to the 2021 analog average. So if you look at the average steering flow here, there's a couple of things going on. Number one, there's that trough again right along the eastern seaboard, and that will act to try to kick storms to the north. So that is an unfavorable for landfall, especially in the Gulf of Mexico towards Texas or whatever. But like 2020, you can see that high pressure over the top the Canadian Maritimes. Maybe it's a little bit further east, but what it's going to do is act and block the eastward progression. So as storms come westward, they will attempt to recurve north, but that high pressure that we're expecting to be there will block them from turning eastward here. So that kind of gives you a little bit of a threat right along the eastern seaboard. You get into the northeast part of the country and into Canadian Maritimes, you might have a chance for some more, a little bit more than this pattern would otherwise suggest. So let's wrap that all up into our 2021 DTN Tropical Outlook. Name storms 20. We're going to go for another active season. Hurricanes, 9 major hurricanes, 4. And the reasons that we just talked about with the steering, we're going to go reduced risk across the central and western Gulf, places that were hit pretty hard last year. And we'll go somewhat elevated across maybe the far eastern Gulf, Florida, up towards the Carolinas, and then again across New England in the Northeast here. But the thing to keep in mind about the northeastern part of the country, even though it is elevated potential, they got about an average landfall rate of a hurricane maybe once every 13 and a half years. So if we're going to go with elevated potential, there's still no guarantee that you're going to get a storm, and the chances are still not great by themselves. But just to keep in mind, all it takes is one, and you'll remember the season for a long time. Just a quick look at our list of names. We have A through W covered here, and we have plus supplemental. So if we get out of control like last year, we'll have some backup names here that'll be different than what we had last year. So let's go to the key messages. Conditions will be favorable for another more active season in the Atlantic, although it should be less active than the hyperactive 2020. Model guidance shows warmer than normal water temperatures and reduced wind shear, both of which will be supportive of more tropical cyclone activity. The analog upper air patterns show Atlantic storms will be more favored to impact the Northeast U.S. and the Florida region, with reduced risk of the western half of the Gulf of Mexico. And the most important thing is, even a weaker tropical system can have a significant impact if it strikes a more vulnerable location or if it's moving very slowly. With that in mind, the tropical section is over here. I'm going to pass it over to Steve Strum, our VP of Extended Services, who's going to tell us all about the forecast highlights this summer. Take it away, Steve.
Thanks, Nate, for taking us through the hurricane season outlook. And as you said, we'll kind of look at some of the non-tropical aspects of the summer season here. So we'll start off looking at the temperature outlook for the June through August time period. And you can see for the most part, most of the country is once again forecast to average warmer than normal. These anomalies are still calculated against the 1981 to 2010 anomalies. They haven't been updated yet to the newer 91 to 2020. But even if they were, it would still show most of the country warmer than normal. They just wouldn't be quite as strong in terms of the anomalies. But regardless, again, a hotter than normal summer for most of the country. But you'll notice that we do look to see, especially in July and August, the core of the warmest anomalies focus really from the plains westward across the Rockies, and not as much along the East Coast. So once we get past June, we may see kind of a more moderate warm pattern for the eastern U.S., certainly still averaging somewhat above normal, but also as a result of having a little bit less intense temperatures, the caveat there is we are going to be seeing higher humidities, and we are going to be seeing, as a result of that, some higher heat indices kind of offsetting the less intense nature of the absolute temperatures that we'll be seeing farther west. The western half of the country will be seeing, generally speaking, less humidity than normal. Normally it's always drier there anyway, but the pattern is looking quite dry across the western half of the country. And so that will be more of a hot and dry regime, whereas the eastern U.S. will be more of a moderately hot but higher humidity regime as we go through the upcoming summer season. Now, looking at rainfall, currently we are seeing a wet pattern right now here for the second half of May across the Plains region, especially the south central areas. And that wetter regime will kind of continue here into June across the middle part of the country with a generally drier pattern for the East Coast. But we should see that shift eastward as we progress through the summer season, and the higher chances for above normal rainfall will be kind of focused more along the Gulf and East Coast as we head through July and August. Now, a lot of that will be strongly influenced by any landfalling tropical systems that might happen to impact those areas. So if we do see a landfalling hurricane that goes into the southeastern or northeastern Gulf and then up the East Coast, you may see a swath of really high rainfall anomalies wherever that storm happened to go. And so we can't really pinpoint where any storm might happen to make landfall. But in general, expect some part of the eastern U.S. will probably see some influence from tropical systems in terms of the rainfall anomalies. But overall, bottom line, kind of a little bit wetter than average for areas along the coast there and higher humidity, but generally trending drier for areas farther to the west. Now, looking at the renewable energy side of things here, looking at the forecast wind and sun anomalies going forward here, we are looking to see windier than average conditions across a lot of the plains regions, so that will be favoring higher wind generation across that area during June, but the transition will kind of take place during the summer to a less windier than average regime for most of the central US by the latter third or so of the summer, and then kind of continuing that into September. We may still see the winds stay a little higher than average down in Texas at times through August, but many areas farther north will be a little bit less windier than typical, and so that will tend to suppress the wind generation just a little bit across those areas. Now, on the solar generation side of things, most of the western U.S. looks to be, generally speaking, sunnier than average as we head through June. July, a lot of our analogs kind of suggest we could see more clouds than average across the Southwest. Part of that is because of some tropical influences in some of the analog years. So if we see a tropical system that kind of juices the southwest monsoon a little bit more for a time, that may enhance the clouds and rainfall for a while down there in the southwest this summer. So we'll have to watch for that. If we don't see any tropical influences, it will generally probably stay more normal in terms of sun, which is typically obviously most of the time during the summer down there. And as you can see as well, areas farther east across the plains will, for the most part, average at or above normal in terms of sunlight during the course of this summer season. Now, looking on the cooling degree day side of things, looking at kind of an estimate here of a potential energy demand, for the most part, that warmer weather will translate to higher than average cooling degree days. We do expect, again, though, potential for some increased warmth across the western half of the country to kind of really be the focus of the higher demand this summer season, whereas the eastern U.S. will be a little bit closer to average. And so if we do see that that warm shift a little bit farther east and get more of the Midwest, more of the Ohio Valley, that will boost CDDs higher than the forecast here. But our warm scenario would give us around 12% higher than average CDD totals, and our cool scenario would only be maybe 2 or 3% higher than average cooling degree days for the entire U.S. for the upcoming summer season. So higher than the 30-year normal. Not as hot as last year overall, or quite as hot as the 5-year average for the country as a whole in terms of both temperature and cooling demand for this upcoming summer season. Now, looking at severe weather impacts, we have had, for the most part, a less active than normal season so far. That is largely because we've seen some periods of cooler weather this spring that have kind of tempered the severe weather development for a lot of the central U.S. Over the last couple of months. We are seeing a more active pattern getting going now, and that should continue here for a while. So we may try to look closer to the long-term average, that black line that you see on the plot on the right-hand side in terms of tornadoes, kind of a metric for overall severe weather. So more active here coming up here in the near term as we go forward, but it won't be certainly as active as some of the really notable years you see on the graph there with those very high tornado totals, but we are trending a little bit more active here coming up. And typically the severe weather season does peak right around Memorial Day weekend and then kind of gradually tapers off during the course of the summer. But we do also see typically a northward shift. So we haven't had a whole lot of severe weather so far this year across the northern half of the country, but that will increase as we go forward here during the next month or so. Now, looking at kind of an area of, or a model, an analog kind of projection here of what we're expecting for thunderstorm activity for the summer season as a whole. And we are looking for the best chances once we get past May for the southeastern U.S. especially, and more of the East Coast, with somewhat less frequent thunderstorm clusters in general this summer season across portions of the Corn Belt especially. So Iowa, eastern Nebraska, and Minnesota could be seeing fewer those big thunderstorm complexes that you typically see during the summer. And so that may also be an area to watch for increased drought development as the summer season goes on. Some of the eastern U.S. thunderstorm activity may also be influenced by tropical systems as well during the course of the summer. But that looks to be kind of the more, the higher focus area for the more frequent thunderstorm development as we go through the summer. And then looking at drought conditions this summer, we already have drought in place across most of the western half of the country. Again, we are looking to see that area of the country be, for the most part, hotter than normal all summer long, and for the most part, also running at or below normal in rainfall. And so we should see the drought expand across the western half of the country. It may also expand a little bit farther east into the plains. And again, we've had that drier pattern across parts of the Corn Belt, and some of the indications suggest you could see fewer, thunderstorm clusters this summer that tend to bring a lot of heavier rainfall amounts as we go through June, July, and August in the Corn Belt area. So again, some risk for an expansion eastward of that drought out of the western U.S. into more of the central U.S. as the summer season progresses. But obviously, with the drought there across that region, we will have to watch for the potential of a higher fire risk for most areas out there once again this summer season. So wrapping things up here, kind of summarizing the overall summer pattern here. The West Coast, moderately above normal, but again, the main focus will probably be more than anything else on the drought that's expanding across that region once again. So again, very high risk for a severe fire weather season as we progress through the course of the year. Most of the Rockies and Plains region generally staying higher than average and drier than average for most of the summer season, resulting in an expansion of the drought across those areas, or if you're already in drought, a worsening of the drought conditions that are already in place. But the southeastern U.S. and the East Coast, for the most part, warmer than average, but not intensely hot in terms of absolute temperatures, but a little bit more rainfall and more humidity in general across those areas will be boosting the heat indices. So it'll be more of a moderately hot but high humidity summer across the eastern third of the country or so, as opposed to the hotter but drier low humidity regime from the plains westward that we'll be seeing during the course of this summer season. And so at this point, before we move on with the rest of the presentation, you should be seeing a poll popping up somewhere in the middle or right part of your screen. So take a minute to answer that while we kind of progress on here. And next up will be Nick Wilson, who'll be looking at how this forecast might be impacting the utility sector as we go through the course of the summer season. So Nick, you should now have control and take it away. Thanks.
Great, thank you very much, Jeff. Let's take a moment so that everyone can have an opportunity to complete the 3-question poll on the right hand of your WebEx screen there. So I'll stand aside here for a moment while everyone continues to submit their responses. All right, hopefully everyone's had an opportunity to provide their quick response there. If not, please continue to do so. So once again, my name is Nick Wilson. I am DTN Strategic Product Manager for Utilities and Energy. I am located just outside of our headquarters here in the suburbs of Minneapolis, Minnesota. Before I dive into a little bit of perspective as far as placing Nathan, Jeff, and the forecast in the context of utility industry threats here for the summer season. It's pretty rare occasion that you get to see yourself invested in the upcoming tropical season. If you looked at the name of planned listed storms, Nicholas is included in the list. So I'm going to do my best to maintain a very low intensity tropical storm peak intensity once we get to my name called this season. So with that in mind, let's take a deeper look here as far as some key messages for the utility industry based on the summer and tropical forecast here. Identify a few utility operational and business challenges that could be faced given the forecast, and talk about a few of the solutions in which DTN can help you improve your operational efficiency and preparations for the events that are likely ahead. So the key messages, to take away from the forecast, as shown, given the low pressure that should fortify itself on the eastern United States, you're going to see an increased hurricane landfall risk in Florida and the eastern seaboard, along with the northeastern United States. Due to that flow, that's going to steer those storms accordingly. As well as Jeff just highlighted, the elevated wildfire risk in Northern California and Pacific Northwest. They're going to see above average temperatures, real dry June. So, the fresh vegetation is going to dry out more quickly than usual, setting the stage for fuel moistures that are appropriate for fire initiation and spread. And there's going to be a strong jet as well over those regions that's going to the stronger the winds, it's a feedback loop as far as further drying the vegetation. In addition to the tropical risks, as you saw, Jeff noted as well that it's going to be a pretty active thunderstorm season across the eastern half of the United States. So the easterly and southerly wind flows from the warm Atlantic waters are going to fuel thunderstorm development. So we can talk a little bit as far as how to manage that threat accordingly. First, before diving into some of the threats that you're going to see, I wanted to take a few of the analog years that Nathan shared earlier that we're setting up at the neutral ENSO phase and identify a couple of early season tropical and hurricane events that did impact the utility industry to a certain significance. The good news here is in searching through those 6 analog years that were provided early in the season, so kind of defining that as June and July, it was very rare that there was a significant impact to utility operations from landfalling tropical and hurricane events. Albeit there were a couple of events that were certainly noteworthy that set up similarly to what we expect this season. First was back in 1996 in mid-July, Hurricane Bertha. So you can see from its track, it made landfall finally in the Carolinas and then tracked along the eastern seaboard and provided wind gusts in excess of 60 miles per hour in Ocean City, Maryland, as well as parts of New Jersey. And you can see on the image there on the left-hand side, a little bit difficult to see, but those dark shades of red represent 5 plus 7+ inches of rainfall. So the biggest concern here, limited, hopefully tracking faster as far as the wind speed and wind gust risk, but certainly heavy rainfall, coastal surge are of critical importance with these types of events. Then if we fast forward to 2013, in early June, Tropical Storm Andrea, this was the first named event of the 2013 tropical season. It originated in the Gulf region, as you can see, and tracked across the Florida Panhandle and remained quite far inland across the Carolinas before it reemerged briefly into the Atlantic and then clipped Cape Cod and Massachusetts. So, as seen here, it was the only tropical storm in 2013 that actually impacted the contiguous United States, but it had extreme flooding once again in the Carolinas, parts of Virginia, and upwards into the northeastern United States. Some of the peak rainfall measurements there were in excess of 7 inches in Williamsburg, Virginia, and in excess of 6 inches in Gales Ferry, Connecticut. So keep this in mind as far as some past events that could similarly be set up for the upcoming tropical season here. Certainly the rainfall threat being the most significant, but winds in excess of 60 mile per hour are potential. Extending in and around the tropical storm risk, things that you're seeking to do as a utility are to accurately forecast the track intensity and time of arrival so that you can coordinate your emergency preparedness and mobilize contractors and other resources in order to restore service as quickly as possible. Additionally, as mentioned with the coastal tracking storms, there's concerns around storm surge and coastal flooding. So you want to be able to target your sandbagging and grid management efforts with the expectation that you're going to lose substation operations and do your best to fortify and ensure that the damage is minimized as much as possible. Lastly, you want to mobilize the restoration crews so that you can achieve your target estimated times of restoration and do your best to demonstrate to the regulators that you've done everything possible to restore service as quickly as possible and avoid potential penalties. There's a wide range of services that DTN provides in and around tropical storm forecasting and threat analysis. First is our tropical storm threat reports. So these are issued on a regular basis, can be customized to key locations across your service region, and we're monitoring with our expert meteorologists the forecasted times of arrival of different wind thresholds, providing updated guidance as far as the probabilities of different wind speeds across the time horizon of the forecast so that you can help justify your preparation. measures in advance of the storm, as well as justify those later to the regulators. We're now, as an add-on feature to our Storm Impact Analytics product, we're providing coastal flooding forecasts where we can customize the forecast locations based on critical substations that you have across your service region, and we're monitoring forecasted coastal water levels, which takes into account the tidal patterns as well as the storm surge forecast, and combines that into a water level forecast. And identify key elevation levels for facilities that are co-located with those substations, so that automated email forecast alerts can be issued when the facilities are threatened, so that you can initiate sandbagging efforts or planning how you're going to manage your grid. Then, our Storm Impact Analytics solution is a machine learning oriented outage prediction system that is tuned for your specific operating geographies, using highly customized weather model data, your outage management system information, as well as your overhead asset infrastructure data and historic outages, so that we can build and tune an outage prediction model as well suited as possible for your service region and your needs. We also have a new feature called Similar Events, where we're able to identify historic events so that have similar meteorological characteristics of the forecasted event. So you can very quickly identify which of those forecasted events are most similar, or historic events are most similar to what's forecasted. You can reference the number of customers out, number of incidents, so that you can use that as another consideration in right sizing your resourcing and the outside number of crews and other resources that are needed to achieve those ETRs. Tropical events are one such outage event type that is specifically supported in Storm Impact Analytics, and specific machine learning models are built around. Secondly, once again, thinking about wildfire risk mitigation. So for wildfire risk, utilities are trying to think about, how do I utilize an accurate weather forecast so that I can take into decision and apply objective criteria in order to fulfill operational wildfire mitigation plans and escalate that risk accordingly based on things like temperature, relative humidity, sustained winds, and fuel moisture, and have access to our expert meteorologists for consultation so that you can discuss nuances around that forecast and how it impacts the decisions that you need to make. DTN has a service called Energy Event Index. This is a licensable add-on to our Weather Sentry application, where you can obtain daily weather and wildfire risk forecasts tailored to your specific service regions. We'll typically create a risk score matrix from 1 being very low, minimal level of risks, to a level 5 or level 4, which has an extreme level of risk, kind of synonymous with like a red flag warning, but tuned specifically to your service region. So this is integrated into Weather Sentry, so that you're monitoring not only the real-time weather conditions, but the risk forecast up to 3 to 5 days in the future, as well as attaining expert meteorological forecast text discussion in context of what the forecast models as well as our meteorologists are identifying. Thirdly, we talked about the increased risk for convective and thunderstorm activity. So, thunderstorm monitoring, utilities are thinking about, accurate forecasts to understand the likely time of occurrence in the coverage area of those thunderstorms. You want to be able to track lightning activity, be able to distinguish between cloud to ground lightning, which is going to attach and impact your assets, versus in-cloud flashes, which may provide context around the evolving intensity of the storm and other aspects of it tied to like hail damage and occurrence and flash flooding. You also want to have automated alerts and all clears to ensure safety around your field crews that are exposed to the elements, as well as understanding the impact to your overhead assets. Within our Weather Sentry Utility Edition application, users can set up a wide range of locations across their service region to monitor and track lightning at different distances away, so that you can escalate and elevate that risk as it gets near your population centers. You're able to track the frequency of lightning within those regions in order to understand how the storm intensity is evolving, We also have now what's referred to as radar scope, which is our single site radar capability, where you can have essentially ground level truth as far as very high resolution weather radar to understand when and where rainfall is occurring. We're able to provide then overlaid on that global precision real-time lightning data for alerting, reporting, and archiving purposes. And specific to your overhead assets, you're able to conduct post-storm lightning inspection reports so that you can prioritize where you're deploying inspection crews and handling repairs based on that information combined with the data that you're obtaining from your outage management system. So with that, I'm going to now pass the baton over to my colleague, Matt Gaffner, who is going to provide an introduction to our DTN, Esri, and ArcGIS data services.
Yeah, thanks, Nick. So I wanted to talk about, in relation to all the great forecast information we saw for the tropical and severe weather season, how some of DTN's ArcGIS-based data service products can really be utilized by our customers. And we have a lot of utilities that make use of these services from DTN, and a lot of utilities do use Esri's ArcGIS platform for their mapping within their organization. So, maybe not everybody on the call works with their ArcGIS deployment, but it's likely that they have some colleagues that do. So just real quick, we've been doing ArcGIS related data services for a long time, and we've been a long time partner with Esri, who's the big provider in the kind of geospatial software world. And we offer a suite of weather data services that come from our ArcGIS server, which makes it so they're plug and play into the data services or the applications that our customers can build with those. So Steve was talking earlier about the high fire weather risk. We've got a handful of data services that we host that can be pulled into the maps and applications that our customers build on ArcGIS, like the red flag warnings. We have an analysis that we do. It updates every 30 minutes with wind speed, relative humidity, temperature, all that good stuff. So in this particular image, you can see, the areas with high winds and low humidity, which are the red colors, those overlay with the red flag warnings. And then also, if you overlay things like SPC fire risk or like the fronts and pressure centers, if you're managing an active wildfire, knowing where those fronts are, if they're going to change your winds, where to position people and how to react is really important. One of the cool things that ArcGIS lets you do is that our customers that use ArcGIS, they've typically mapped out all their assets, whether it's substations, transmission lines, distribution lines, but they also map out a lot of their kind of dynamic data sets, like if they've got automated vehicle location sensors, GPS information that's reported back for all their vehicles, they can overlay that in the maps that they create in their ArcGIS system, which is really powerful to have all that data mashed up in one location. And I'll talk a little bit more about that later. And then on the severe storm side, there's a handful of data sets that we provide. This by far doesn't cover everything, but what I wanted to highlight here is the ability that Esri provides for customers to build out dashboards that they can put in real-time information. So this was a dashboard I put together to just highlight how our real-time watches and warnings, lightning, radar data can all be pulled into an Esri-based dashboard with the customer's information overlaid on top of that. And then there's an ability to create little widgets like I have on top that can identify and quickly draw attention to things that are of interest. So if you've got it up on an ops wall, you can see how many lightning strikes there are in the area, and it's all responsive. So if you zoom out, those numbers change, or if you want to see how many tornado warnings there are, those are all really useful functionality that Esri provides with their operations dashboards, and our data plug right into that. In talking about an active storm season, obviously the tornado risk and severe storms was something that Steve addressed, a little bit lower than average to date. But if we see that creep back up, we'll probably see a lot more tornadoes. And this is a cool product we have. We've called it Tornado Tracks, where kind of the blue to orange to red polygons, that's basically a swath that updates in real time to show where a rotating storm has been. Doesn't necessarily tell you if there's a tornado on the ground, but those red triangles are storm spotter reports that update in real time as well. And that can provide information as to whether, the rotating storm actually put a tornado on the ground. And I've overlaid this with some transmission assets, so you can kind of get the idea of how, if you're using it in real time, overlaid in your system, you could see and kind of get an idea of what assets to inspect, where to send crews and all that stuff immediately, instead of having to wait for people to drive out and report back as to what's happening on the ground. So in addition, we also have tropical data sets that you're used to seeing in products like DTN's Weather Century Online. We've got the National Hurricane Center forecasts. I don't have it in here because they look nearly the same, but our weather ops forecasters that create their own tropical storm and hurricane forecasts, they look very much like this, but they often may vary in intensity or track from what the Hurricane Center has. So those data sets are all available, so they can be pulled into the ArcGIS environment that many of our customers use, along with the tropical storm models as well, the spaghetti plots, as you may have heard them referred to as. And then in addition to that, we have some cool rainfall analysis products. I didn't have an example in a coastal area, but I did have this one handy, where we combine radar data with rain gauge information. So obviously, in this particular event, you can see 4 inches or so along the Oklahoma and Kansas border. But for instance, when Hurricane Harvey made landfall, there were 30 to 40 some odd inches that were showing up in this product that tracks the precipitation accumulation. So those are some cool things that you can pull into those types of dashboards as well. So one of the things that I wanted to talk about was kind of the patterns and practices that we see our utility customers using, and kind of similar experiences as we work with more and more of those customers when it comes to how they utilize Weather Century versus ArcGIS Online. And the two, or not ArcGIS Online, are ArcGIS-based weather data services. And the two, they really are very complementary in the fact that Weather Century does a great job at sending alerts, whether it's to mobile applications or SMS or emails, whereas that's not something that our data services are intended to do. They're intended to be put on top of a map that's been created in the customer's environment. Weather Century is a great out-of-the-box display. The data services that we provide, it's not a weather map out of the box, but it's weather data services you can take and make any map have that weather intelligence layer on it as well. And it's not a point forecast, and Weather Century obviously does a great job at providing forecasts. Now, Weather Century does have the ability to overlay some of your data on top of it, but you have to provide that to DTN, and then DTN has to update it. It's not nearly as dynamic, but if your organization were to be using ArcGIS to build out all kinds of maps and applications, you can take our weather data, which is updating in real time as new data comes available, and put it on top of all of your transmission assets, substations, AVL data that you have. And that's what creates a really powerful experience when you guys can build those applications with the ArcGIS environment. On top of that, there's all kinds of geospatial operations that you can do to determine the proximity of a lightning strike to a wind turbine, or determine if a asset is within a polygon, like a National Weather Service watch or warning or something like that. But one of the biggest and most important things that we really see our customers doing is, as emergency management operation centers, network operation centers get bigger and bigger and bigger, they have more screen real estate. And with all of that, those screens, they don't necessarily want to see more and more displays and more maps. They want to see less screens so they can overlay things all in one application. And so that's what we see a lot of our customers leveraging their ArcGIS investment with DTN's ArcGIS data services to overlay that information so that they have one single authoritative map, which is so much less stressful for those operators. Instead of trying to look at two screens, maps can be in different projections. So, if it's over here in one map, is it over there in one map? That's really something that makes it a lot more valuable for those customers that are using ArcGIS. So with that, that's all I had. I hope those examples were useful, and I'll hand it back to Andrea or anybody else to kind of finish it up from there.
Thanks, Matt. If anybody has any questions, please go ahead and put them into the Q&A or the chat feature on the right-hand side of your screen. Jeff, Nate, or Stephen, do you see any questions that have come in?
Oh, I think I see one.
Okay.
Jeff, do sea surface temperatures favor increased risk of close-in development? Do you think the current forecast would suggest that there will be a greater or lesser risk of that?
Well, typically we see the close-in development early in the season, the June, July, maybe into August type storms where they form in the northern Gulf or in the vicinity of Florida or off the southeast coast. So with the warm sea surface temperatures just about everywhere, I think the potential for close-in development early in the season is certainly with us this year. As we move more into the latter part of the season and we get that eastern trough developing that Nate showed us in the presentation, that steering current probably would tend to take any close-in development in the northern Gulf and tend to want to move it more eastward toward Florida and then out to sea. So yeah, it's hard to say we're going to be safe from close-in developments this year, but because they can form with pretty short notice and not too far off the coast. Probably one advantage, if there's an advantage to a close-in storm, is they don't have a lot of time to really wind up into really significant systems for the most part. So they do tend to be more on the lower end of hurricanes or tropical storms, but still those can be highly impactful with heavy rains as well as severe gusts near the center. So summarizing, I think if we do see close-in storms, probably the best chance is at northeast Gulf and around Florida. And then as we move later into the season, those tend to be more of the longer track systems coming in from Africa and moving westward across the Atlantic. And hopefully most of those do get steered out to sea, but some of those could turn up and impact the northeastern part of the country.
Thank you very much, Jeff. Another question came in. Does this outlook give any indications of derecho potential? Do you have any thoughts on that, Steve?
I'm sure. Yeah, for the most part, those are challenging to anticipate whether you're going to see, more or less. However, the one indication is in terms of where they may tend to occur. A lot, we saw the big one last year, I think, in Iowa and in Illinois, and we had one a couple of years ago that went into the Mid-Atlantic. The overall pattern this year is going to be more favorable for thunderstorm complexes to develop kind of farther east. So I think there's probably less risk that we'll see a major one, this year across, like the western part of the Midwest and the Plains region. So less risk for Iowa probably this year, but maybe an enhanced risk for one to develop somewhere, in the Ohio Valley or Mid-Atlantic states this year. Obviously, those real intense ones that we've seen are not ones that happen every year. You always usually see a few of them that develop, that are significant every year. of lesser intensity. So odds are we will still see a few of those events take place, but in terms of those really impactful ones like we've seen a couple times here in recent years, those are not certainly an every year event, at least certainly not in the big population areas. So, it's always a lower risk for those types of extreme events. And the overall pattern this year is somewhat less favorable across, the middle part of the country again for that to happen. So if we do see one, odds are it'll be one that tends to impact the eastern Midwest potentially, or somewhere in the southeast this year, instead of farther west in the plains and western Midwest.
Another one came in. Does this mean the storm track or the jet stream will stay to the north, across Canada, or more across central US, and direct west to east, or is it going to be northwest to southeast? Well, I can take this one. I think the jet stream, according to the analogs, the jet stream will more or less be stretched from the northwest US through the plains, and then it heads through near or just south of New England into the northern mid-Atlantic. It does show somewhat enhanced jet stream winds in those areas with lesser winds across portions of eastern Canada and the southwestern part of the United States. So usually when you're looking for the tracks of these types of things, you can find it right along enhanced portions of the jet stream. So right now, during the early part of the summer, there's been a bit of southwest flow that goes across the central United States. And that might last into the early part of June, but there will be some opportunities where that becomes more west to east or even northwest to southeast. And I think you'll find that that occurs a little bit more as we get into the second half of the summer. So if, let's say, thunderstorm complexes were to be able to develop somewhere across the plains or the Midwest, they would come east and probably track southeast, just as Steve just mentioned here. So hope that answers that question properly. And I don't think I see any more questions unless anybody else does. In which case I'll pass it back to Andrea to close.
Great. I want to thank everybody for joining us today, and especially our panelists, Jeff Johnson and Nate Hamlin and Steve Strum, along with Nick Wilson and Matt Gaffner. Thank you all very much for a great presentation. Like I said in the beginning, I will be sending out a recording of our presentation when we have it ready and available, probably in about 1 to 2 weeks. So please take a look for that. So with that, I hope everybody has a great rest of your day, and thanks again.